In this section, we're going to learn how to add, subtract, multiply, and divide two functions. So first, let's familiar with some of the notation. If f and g are two functions, and then add function f and g, we can define by this expression. Use the function name f plus g in the parentheses, and then enclose the independent variable x. That's this notation equivalent to f of x plus g of x. Okay, so that's how we define add two functions together. So instead of write it out f of x plus g of x, we just write the two function name and add them together, enclosed in the parentheses. That's represent the two functions add together. And similarly, how to represent two functions subtract. We use this notation, f minus g in the parentheses, and then another parenthesis of x. That's indicate this f of x minus g of x. And a similar notation apply to the two function multiply and divide. Parenthesis f times g, close parenthesis of x. That's equivalent to f of x times g of x. And then divide, we use f divided by g, use the function name, and then independent variable x, that's the same as f of x divided by g of x. Okay, so that's how we define adding, subtracting, multiplying, dividing the two functions. Oh, of course, the denominator g of x cannot be 0. Okay, that's the same as real number. All right, now let's look at some example. If f of x defines as 1 divided by x plus 2, and g of x defines as x divided by x minus 1, and then we want to perform add these two functions together and then subtract and then multiply and divide. Okay, we're going to do one by one. So do the adding first. Okay, write a. So function f of x plus g of x. Okay, we first just plug in by its definition. F of x is 1 over x plus 2 plus g of x, that's x divided by x minus 1, right? So now we have two rational expressions with different denominator, right? In order to combine these two terms, we need to find the LCD, right? So LCD for the factor x plus 2 and the factor x minus 1, it just these two multiply together, which is x plus 2 times x minus 1, because there's nothing common to both binomials. Okay, so we just have to multiply these two binomials together as the LCD. All right, so now we rewrite each of the rational expression with the LCD. So the first one, original denominator have x plus 2, but the LCD, we need to multiply x minus 1 in the denominator. So numerator also need to multiply by x minus 1, right? So we still remain everything equivalent. So here original 1 multiply x minus 1, still x minus 1. But I just want to make sure you follow my logic. Okay, so I write in detail. And the second term, x over x minus 1. So first we write x over x minus 1. Okay, and then the LCD is x plus 2 times x minus 1, right? So when denominator, we need to multiply by x plus 2. In order to keep equivalent numerator, we also need to multiply by x plus 2. So now these two rational expressions have the same denominator, which is x plus 2 times x minus 1, right? So now we can simplify the numerator. So here we have x minus 1. Here we have plus x squared plus 2x. And then combined together, we have Denominator is x plus 2 times x minus 1. Numerator is x squared plus 3x minus 1. But here, what about the domain of the addition of the two functions? So let's find the domain. Okay? So for f of x domain, denominator cannot be 0, right? So x plus 2 cannot equal to 0. This is coming from function f of x. And then g of x also have a denominator, so denominator cannot equal to 0. Okay, so x minus 1 cannot be 0. This coming from function g of x. Since f plus g involve both functions, that's why these two restrictions need to be as the domain of the adding these two functions together. Okay, so we summarize if write in the set notation. Okay, independent variable x, and then put a bar separate variable name and a condition. So x cannot equals -2, right? Solving this equation, and x cannot equals +1. That's solving from this restriction. Okay, that's the complete for A. Find the summation of function f of x and g of x. And the subtract is doing the same way. Okay, the only thing now changing this part to subtract. Okay, can I write it as a short? Okay, I write here B. Okay, f minus g of x. So first part is the same. Okay, it's still is 1 over x plus 2 minus x over x minus 1. Okay, and then do the same LCD and then rewrite. Okay, so I can just copy from here. Okay, that's x minus 1 over x plus 2 times x minus 1, right? That's the first term. And then minus, and then x times x plus 2, that's numerator. Denominator is x minus 1 times x plus 2, right? So now they have the same denominator, x plus 2 times x minus 1, and then numerator will be x minus 1 minus x squared, right? The negative sign, x times x, and then negative sign, x times 2, minus 2x. So be careful, the two negative sign here. And then we can get numerator is negative x squared, right? And then minus x minus 1. Denominator is x plus 2 times x minus 1. So if you see numerator, every term have negative sign, and then if you wanted to, you can take a negative one out. Okay, put a negative sign in the middle, and then denominator is still x plus 2 times x minus 1. Numerator, you can do, since you already factor negative sign out, so numerator, everything become a positive, right? X squared plus x plus 1. Okay, you can do that if you wanted to. If you do not want it to, you leave as this is the answer, that will be fine too. All right. And then domain is the same as A, because x cannot equals -2. That's coming from function f of x. And x cannot equals +1. That's coming from function g of x. Okay, that part doesn't change. Okay, so that's the part B. Part C. I don't have space below, so I move the top, okay? Two function multiply f times g. So that's 1 over x plus 2 times x over x minus 1, right? The two multiply. So that will quite easy. Numerator times numerator. Numerator is x. Denominator times denominator, that's just x plus 2 times x minus 1. Okay, so nothing can be further simplified. We just have to leave like that. And then the domain is the same. Okay, domain is x cannot equals -2, x cannot equals +1. Same reason, okay? X cannot equals -2 coming from the restriction of f of x. x cannot equals positive 1, that's coming from the restriction of g of x. So in order to make these two functions have a meaning, and then x has to be, excluded this two value. All right, and then D, f divided by g of x. Okay, and then if we write it out, f of x based on definition, that's 1 over x plus 2, and then divided by g of x by definition, that's x over x minus 1. So this is a complex, right? Complex rational expression. So now we can rewrite it. Vertical direction, right? Numerator divided by denominator. So 1 over x plus 2 divided by x over x minus 1 is equivalent to multiply by reciprocal. So it's equivalent to multiply by x minus 1 over x. Is that right? So we rewrite vertical division into horizontal multiply. Okay, so that's why we got numerator is x minus 1, denominator is x times x plus 2. And then this time the domain will be changed a little bit, right? So again, we have x cannot equals negative 2. That's restriction coming from f of x, function f of x, and x cannot equals positive 1. This restriction coming from function g of x, and then we have one more restriction, right? If you look at after we divide these two functions, and then we have a new factor on denominator, which is x. So x cannot equal to 0. Okay, if x equal to 0, also denominator is undefined, right? Denominator equal to 0, and the whole expression will be undefined. So these two functions do division, okay? The domain, okay, x cannot equals negative 2, cannot equals positive 1, and cannot equal to 0. So we have added one more restrictions. All right, that's how we do add, subtract, multiply, and divide two functions.